going to practice writing equations given graphs, but first we need to review end behavior. So let's try these examples where you're going to sketch a graph with odd degree positive leading coefficient, odd degree with a negative leading coefficient, and then even with positive and even with negative. So try these out. Pause the video. So odd degree, odd goes in opposite directions. So it's going to go up on the right and down on the left. So opposite direction. So again, I'm mainly focusing on the end behavior. Anything could happen in the center. Could do something like this, just as an example. So the second one is odd and negative. So odd still in opposite directions. So think about that as a negative slope. So up on the left and down on the right. Then anything can happen in the center. Could make a wave here and then come back down. Even degree and positive. So think about a parabola. Even goes in exactly the same direction, exactly the same. And if it's positive, it's going to go up and up. And then the middle part could be anything. So let's just make it a parabola. And then even and negative, they're going in the same directions. So it's going to go down and down. And then anything can happen in the center. Now the main part of this is when it's negative, then so when we're looking at our graphs, we need to be careful and put a negative in front of the entire function, right? So we're going to write our function. If it's negative, we need to make sure and place it there before we start writing everything else. So that's what's important about identifying the sign, whether it's up or down. So that'll help us out in a little bit. So let's try this example here. Given the graph below, we want to identify the degree, the leading coefficient sign, because that's going to help us overall with our function. And then we want to write the polynomial in least degree with the leading coefficient of 1 in factored form. So we're not going to focus on trying to find what a possible, the leading coefficient number is. We're just focusing on our X intercepts and our end behavior. So we want to look at on these graphs is just to find out if it bounces at any point on the x-axis or off of the x-axis. So if we have, just for an example, if it bounces, if you recall, then it'll touch at that point on the x-axis and then come back up. So it makes like a U shape. The other option is when it crosses the x-axis. So we'll come back down. And notice it crosses the x-axis, right? It passes through it. So anything that bounces, we're keeping it lowest degree. So what that means is whatever this x-intercept is, when it bounces in factored form, then it's going to have a square. Now, if it crosses, then it's going to be to the power of 1. We're not going to make it any higher power than that. So remember, when something crosses, it has an odd power. So 1 is odd. When it bounces off of the x-axis, then it is squared. So looking at the first example, if I trace my finger on it or my pen on it, notice it passes through every single one of the x-axes. Okay, so we're not going to worry about the y-intercept. We're focused on the x's. Now, if we recall to writing the x-intercepts, so -5 here, so if x equals -5, to write it in factored form, it's the opposite, x plus 5. So if x equals -2, then factored form is x plus 2. It's the opposite, and this is x minus 7. So let's talk about the degree. So the degree, I want you to look at the end behavior. Do not focus on the x-axis. I want to focus on the end behavior. So notice it's going in opposite directions. Therefore, we know that it's odd. If it's opposite, it's going to be odd. Now look at where it's going up versus down. So we know that if it's going up on the left and down on the right, up on the left means it's a negative, I think about a negative slope. And so the leading coefficient sign then is therefore negative. So then the first thing I want to do, if I know that the leading coefficient's negative, then I'm going to put a negative in the front. Then I write the factored form. So here, x plus 5, again, the opposite of x equals -5 is the factored form of that. So x plus 5, then we have x plus 2, then we have x minus 7, and there is our function. Number 2, it's the same. Okay, looking at it, it passes through every single one of the x-axes, right? It doesn't bounce, it doesn't make a U shape. It's not making a U shape anything on the x-axis. Same here, right? It's passing through each and every time. Let's see, the degree, the ends are going the same direction, exactly the same. So therefore it tells me this is even and it's pointing up, so it's positive. So I don't have to put any signs here on the front, right? It's positive, that's what it tells me. Then I'm going to have 4 X intercepts. There's no bouncing. 1, 2, 3, 4. And remember that it's opposite. So -4, we'd actually write the opposite of X plus 4. For -1, we'd write X plus 1. This is X minus 2 and X minus 6. So I'm going to write that down here. X plus 4, X plus 1, X minus 2, and X minus 6. And you can verify, right? It should be an even degree. So from the last video, when we graphed it in factored form, we would count the number of x's. Notice I have 1, 2, 3, 4. That means it's even. And then we know it's positive because it's up. Let's look at an example where it bounces. Okay, so here are 2 examples where it bounces. So the degree in the third one, that is odd, because it goes in opposite directions. It's up on the left, down on the right. Now again, this is a negative leading coefficient sign. And so I know, let me write it right away, is that when I'm writing my function, I have to put a negative sign in front. Now I notice, so see, when I'm tracing my graph right on the x-axis right here, it bounces off of that x-axis. It is not passing through. So this is the case where it's going to be squared. So we would write it, so because x equals -2, factored form is x plus 2. And because it bounces or just touches, it does not pass through, therefore it is squared. X plus 2 squared. So that binomial is squared. Then the right one, the 5, so if x equals 5, the factored form is x minus 5. Now it passes through the x-axis, therefore it's just a power of 1. So when we write this polynomial, it is x plus 2 to the square, because it bounces at that -2, times x minus 5. So try example 4. Now, as a hint for the 0, you could write it as x minus 0 if you would like to kind of keep consistent with it. That is fine. But notice that x minus 0, that's just x. So just kind of keep that in mind. Okay, either one is fine. You can write this. Normally when we see it is always written like this, but this is okay for now. Okay, so try this out. See if you can find the degree, the leading coefficient sign, and see if you can try to write it in factored form. All right, so we have an x-intercept at -5, so therefore it would be x plus 5, and it passes through, so it's just to the first power. Now, it bounces here at the 0. Notice it doesn't pass through. So what that means is it's squared, so it's either the top one or the bottom one. It's up to you. Then this last one at x equals 3, to write it in factored form, it's the opposite, and it passes through, so it's to the first power. Now let's look at the end behavior. So our degree, because the ends are going down and down, they're going the same direction, that means it is even. And the leading coefficient sign, because it's going down, is negative. So if I were to start writing my polynomial, then I know I need a negative in the front. And then now let's start writing our factored form. So x plus 5, again, it's to the first power because it passes through. Our next one is, I'm just going to write an x minus 0 squared here, because it bounces, so I already wrote it on my graph. The last one is x minus 3. And then if you would like, you can change it a little bit. So it's negative. I'm going to move my x squared to the front, x plus 5, and x minus 3, and that is done. Now, one thing you're going to have to do is to multiply the polynomials through. So you get to pick 3 of them to do that with. So just a quick review. Number 4, if I were to multiply number 4 out, negative x squared, x plus 5, x minus 3. So use whatever method you are comfortable with multiplying. So for example, the box method, I'm going to multiply the x plus 5 and x minus 3 first. Okay, and then I simplify. So I have my x squared that I'm ignoring for now. And then what I'm multiplying here becomes x squared plus 2x minus 15. And in this case, last I just distribute. So this is negative x to the fourth minus 2x cubed plus 15x squared. And so what this does, when we multiply it, we write the function in standard form. And so you'll have to practice, just pick 3 out of all of these that you would like to do. Now, as a hint, you probably won't want 12 because there are 5 X intercepts there. That's pretty large. Something with a 4th degree that is a bit of a work too, just depends. But it is possible, and it's great practice on multiplying polynomials.